A single-phase induction motor is rated at 500 RMS voltage, 10 horsepower, 85% efficiency, and 0.6 power factor lagging. Calculate the motor current in amps. So this is a very straightforward problem, but I understand sometimes NCES will solve. I mean, this is a typical example from the NCES. But sometimes they solve problems and they can either go on and then you get lost, or they just leave out solutions that's very, very vague, and you kind of don't understand where they get certain things from. But if you recall, this is an FE example problem, but you may also see something like this in the PE power. It may or may not be as straightforward, but they may ask you about losses, or like like your I squared R losses, or rotor power, iron losses, things like that. But it's kind of sort of interrelated anyway. But this is the formula, right? Remember, motors, they convert electrical energy to mechanical energy. That's the opposite of a generator. A generator converts mechanical energy into electrical energy. So if for instance a motor is said to be, let's say, 100% efficiency, what that means is that all your electrical power is converted to mechanical energy. And of course, there's no such thing. There's no such motor. And that's the reason why they give you sometimes, it's telling you that the motor is 85% efficiency, meaning at 85% it can convert electrical power into mechanical power. So your output power, which is mechanical energy, this is a motor, this is a formula, standard formula, is equal to V times I times power factor times efficiency. And remember, efficiency is your output power, your mechanical energy, over input power, your electrical energy, because this is the motor, right? Converting electrical into mechanical. So this is the formula for efficiency. I don't know how they call this a Greek letter, but that's the formula for efficiency. So and also we have that 1 horsepower is equal to 746 watts. This is something to remember as well. It's in your, I think it's in your FE handbook. I'm not sure if this formula is in there, but I've done a lot of problems, PE problems, where I needed this, so that's where I remember it. So 1 horsepower is 745.6 something. So generally speaking, we use 746 watts. So that's something to remember. So your mechanical energy, this is the formula for your output power. So of course, to get the current, this is what we have. I is equal to, just plug in, is equal to output power, right, divided by voltage times power factor times efficiency. Now from here on, it's just plug in. Your output power is your mechanical energy, so which means you have 10 horsepower, but 10 horsepower is equal to 1 horsepower is 746. So you convert that into watts, because you're dealing with watts here. Let me just put 10 horsepower here, and then we'll convert so that you see what I'm doing here. So 500, the voltage, power factor is 0.6, efficiency is 0.85. Right? So you can't use horsepower, so you got to convert that in watts. So you have 10 times 746 over whatever this is, 500. Let me just write it down again. 0.6 times 0.85, I'm sorry, 85 for the efficiency. And efficiency is typically given in percentage. Alright, so plug this into your calculator. 10 times 746 divided by 500 multiplied by 0.6 multiplied by 0.85. The answer is 2925 amp. 2925 amp. Now I changed this a little bit, but it's the same. It's kind of changed the numbers here a little bit, but it's the same example as some of your NCES example problems here. But this is the formula that you got to use in order to solve the problem. And looking at the solution, sometimes it can get confusing, but remember that 1 horsepower is equal to 746 watts. Efficiency is how much you're putting out versus how much went in. In case of a motor converts electrical energy into mechanical energy. So this is your output power, this is your mechanical energy, and this is your electrical energy. And there's no such thing as a 100% efficient motor, because you're not converting all your electrical power into mechanical. There's no such thing. Typically, the motors are not even. I don't know if I've ever seen a motor that's like 85. That's a pretty good motor out there. So typically, it's between 60, 70, or even 50% efficient. So this is a formula to remember. Essentially, convert your horsepower into watts and solve your problem. So if I've changed the values here a little bit, but you get the point. So if you have any questions, let me know. Thank you.